So there were clearly limitations that you could see with that. So what started to happen over the course of time is the attempts have been made to increase the validity by reducing the variability in the test. And one such approach was put forward by Patterson and colleagues in '96, which is what's called the Backsaver sit and reach test. And in the Backsaver, you can kind of see what is going on here. So you've got a participant, and what they're doing is they're actually outstretching just one leg. I'll explain why that is the case in a moment. So one foot is placed against the box, the other leg is out of the way. Don't worry about the person behind them. They're using a more direct tool here, which is a goniometer, to assess flexibility in this example within the spine region. But it was designed to assess the flexibility of each leg independently, which the classic Wells-Endilian sit and reach couldn't do. So remember, in the Wells-Endilian, both feet are placed flat against the box. This allows for independent assessment. Now that's quite useful in a sporting perspective. It's useful in a rehabilitation perspective. So that actually that increases the validity of the test. Does it, though, reduce the variability in the data? Well, the authors argued that it probably does reduce the variability, because their argument is it reduces the resistance to stretch of the lower back and therefore provides a better indicator of lower limb flexibility. Now that's quite interesting, because what the argument is by having only one leg engaged, it causes a relaxation in the lower back. So in this example here, we've only got the right leg being engaged, left leg is not in play in this example, therefore it increases a relaxation, therefore they're more likely to get a valid measure. In this case, their argument is of lower limb flexibility. Now therein lies perhaps part of the issue, is it still lower limb flexibility? How much of this is lower back and so on? But there is certainly a rationale here for the argument that they are making. It's got, apparently, a good test-retest reliability, but they've done this using simple correlations. So they've correlated test 1 to test 2. Remember, correlations don't show reliability. They don't show causality. They certainly don't show reliability. So using perhaps more appropriate indices, which I'll show you some in a moment, would be a better way of identifying where we've got good reliability. So here's a data set. This was published a while back now in MedSci Sport and Exercise, and it is interesting that there are not vast amounts of studies on flexibility and range of motion exercise science, because it's not a very well researched kind of test that is being used. So in this data set here, this is from a Chinese group. They've done a slightly different version of the test. So you can see there are different versions of this, which increases the variability, particularly when you're comparing across study groups. But what they've got here is, we're going to focus on what they got as the standard Backsaver. So this is the normal Backsaver. And what they've done is they've used what's called an interclass correlation. It's not a standard correlation. So an interclass correlation allows us to assess reliability using the basic premise of correlation analysis, but with a kind of a slightly more nuanced twist. So the same thing applies. The higher this value is, or closer to 1, in this example, the greater the reliability. So here's the conventional Backsaver that we saw on the previous part of this slide deck. And they're in quite good agreement. They're actually saying, look, in the right leg, it's 0.98. In the left leg, it's 0.93. And this is in men. In women, 9.7 and 9.7. So that's really quite good. When they use this modified version, and they argued that actually doing this really reduces the resistance to stretch in the lower back by doing it this way, what they found was actually there was almost no difference in terms of the reliability. Men, this is the modified 9.6, 9.7 for left and right, and in females 9.7, 9.7, absolutely identical in the females. So it does tell us that there is quite good reliability in these tests. The question is the validity. So we've reduced the variability, but how valid is it? Well, that comes down to what we've been saying. You're still simply measuring linear displacement. You still have no idea in this, where is the outcome variable being derived from? What is the primary contributor from this series of joint articulations to this displacement that they're measuring here? So you start to understand why these tests have really been described as being meaningless. Now, if we then come to this paper, this is a 2009 paper, published in the Journal of Sports Sciences and Medicine, and they've done the same kind of thing here. What they've done is they've got our modified sit and reach. Now, what they've done is they have then recorded the articulation around different regions of the body. So if we go back, just show you how they did it. So here we've got our participant. They're using this little goniometer device here. It's like a protractor, and as you place it on the body, there's kind of a needle that spins. It allows them to kind of record articulation. So what you've got is we've got these different versions. Here's the thoracic angle, and sit and reach, and then they've got Backsaver right and Backsaver left. And you can see actually thoracic angle is pretty much the same between left and right, but it's actually considered to be significantly different to the conventional sit and reach test. Lumbar is the same, pelvic position is the same. The scores, interestingly, despite this viewed significant difference here, actually resulted in no significant difference in the overall linear displacement measurement, their indication of range of motion. That's both in the same of males and females. It's quite interesting that despite the fact that they're altering, or they're arguing they're altering thoracic position, it doesn't seem to be altered, say, lumbar and pelvic, it's not actually manifesting in a change in the overall linear displacement, the overall score of range of motion. Now, these data sets here are assessment tools being used to assess validity, which is on our x-axis. And what you've got them for is sit and reach, which is panel A. You've got them for modified sit and reach and B, which we haven't looked at yet, and the Backsaver, which is panel C. So we'll just focus on panel C and panel A. And the fundamental thing that you've got to look at here is yes, you've got sample size. And then what we've got here is this kind of the degree of validity on this x-axis. So what it's telling us is how well is that data spread. So if that data is tight to this kind of mid-axis, then we've got good agreement. And actually, that's reasonable agreement here. And it's reasonable agreement here, it's a smaller sample size. Much, much wider displacement in the Backsaver. So the argument that the authors put forward here is that there's perhaps more validity in using the kind of the Backsaver as opposed to using a traditional sit and reach test. But it certainly needs much more food for thought. These are quite small sample sizes to be making quite significant conclusions.